In this video, we're going to take a look at mutually exclusive and independent events. So to begin with here, let's take a look at the definition of mutually exclusive events. I'll just make a note here at the top for mutually exclusive. So mutually exclusive here. And what we say is if two events are mutually exclusive, then they can't both occur at the same time. So to best illustrate this, let's just quickly draw a Venn diagram. Don't have to be perfect, just so we can see the two events here. Let's say I've got two events, A and B. Let's say that's A. Let's say this is B here. And the key point here, what I want to show for mutually exclusive events, is there's no overlap. So there's no intersection there between those two events. In that case then, for the probability of A or B, so A union B, this is equal to the probability of A plus the probability of B. Okay. So that's everything we need there for mutually exclusive events. Now let's take a look at independent events. So for independent events again, let's just make a note here. So independent events. Then what we say is when one event doesn't affect another, then they're independent events. Okay. And for independent events, we have a way of checking whether those two events are going to be independent. So the way we do that is by using the probability of A intersection B is equal to the probability of A times the probability of B. Okay. So like we said, this gives us a way now to check whether two events are independent. In this case, what we'll be checking here is whether the events A and B are independent. Okay. And that's simply all we need there for our introduction to mutually exclusive and independent events. What we're going to do now is take a look at some practice questions on mutually exclusive and independent events. If we start with question 1 here, we've got A and B, which are the events such that the probability of A is 0.3, the probability of B is 0.7, and then the probability of the intersection here of A and B is 0.21. So the question says here to determine whether the events A and B are independent. So remember, these two events here, A and B, will be independent if the probability of A times the probability of B is equal to the probability of the intersection of those two events. So the probability of the intersection here of A and B. Okay. So the probability of A, that's 0.3. And times it by the probability of B, which is 0.7. So 0.3 times 0.7, that would give me 0.21. And notice here, this 0.21, that is equal to the probability of A intersection B. That's 0.21 as well. So we just note that here. Okay, so that is equal to the probability then of the intersection of A and B. So therefore, in that case, what we can say then, so therefore A and B are independent. Okay. And there we have it. So that's all we need to do there for question 1. That gives us the solution to question 1. We move on to question 2 now. We've got A, B, and C, which are the events such that the probability of A is 0.32, the probability of B is 0.25, and the probability of C is 0.2. So for part A, we're given that B and C are independent, and we're asked to find the probability of B intersection C. So to find the probability here of B intersection C, we can do that using this fact here that B and C are independent. Because if we know that B and C are independent, what we're saying then is the probability of B multiplied by the probability of C here, that will be equal to the probability of the intersection of B and C. Okay. The probability of B, that is 0.25. The probability of C here, that's 0.2. So 0.25 multiplied by 0.2, that would give me 0.05. We get 0.05 there. What we're saying then is the probability of B intersection C here is equal to 0.05. Okay. Like you can see, it's as easy as that. So that's our solution to part A. Now, try again for part B here. There's a tiny little mistake, so this should be the probability, let me try it again, probability of A union C here, okay? So we're given that A and C are mutually exclusive, so we're asked to find the probability of A union C. So for the probability of A union C, well, if we know that A and C are mutually exclusive, like we're told here, then A union C will be the probability of A plus the probability of C, okay? Well, the probability of A, that's 0.32, so therefore, probability of A union C, like we said, that's 0.32. What's the probability of C, which is 0.2? And in that case, that gives us 0.52 there. Okay, and there we have it. So that's our solution to question 2. And finally, we take a look at the very last question. Here we've got the events A and B, such that the probability of B is 0.4, and the probability of A union B is 0.62. We're given that A and B are mutually exclusive, and we're asked to find the probability of A. So remember, if we know that two events here, A and B, are mutually exclusive, what we can say is the probability of A union B will be equal to the probability of A plus the probability of B. Okay, so if we know the probability of A union B, that's 0.62, and we also know the probability of B, so that's 0.4, and we can easily find the probability of A here by solving this as a linear equation. So the probability of B is 0.4 plus 0.4 there. Obviously, to just find the probability of A now, I just need to subtract 0.4 off both sides. So therefore, the probability of A equal to 0.62 minus 0.4, which gives us 0.22 there. Okay, 0.22. And there we have it. So that's our solution to question 3, and that brings us to the end of this video on mutually exclusive and independent events. In the next video, we're going to take a look at tree diagrams.